I'm doing Unit 9 on thin lenses, and I'm going to be drawing ray diagrams to find the position of an image and talk about the characteristics of each of the images. Okay, so for the first one, draw the axis. We have focal point is here, and the object is at infinity. So the first ray, focal ray, will, oh, I forgot to draw this. This is the front. For all of these, they're going to be converging lenses, which means the front of the mirror is going to be here, and the back of the mirror is going to be here. So I'm going to write front, back. Okay. So the focal ray is going to go through the center. And then the parallel ray, the central ray, will be like this, and they'll be perpendicular, and like this. When the object's at infinity, the point image is at F. So the image would be here, but there's not really an image because of the object's at infinity. For the second case, we're going to have the object at past 2F. Okay, so when the object, we're going to have that guy right here, is past 2F, we have the central ray, which is going to go right through the center. We have a parallel ray, which goes parallel and then through the focal point. And then we have the focal ray, which goes through the focal ray and then parallel. Since these all end up here, the image is produced between F and 2F. When this happens, the object outside 2F image is inverted, smaller, but is a real image, and it happens between F and 2F. That is case 2. Next we have case 3. Case 3, we have an object at 2F. And now let's draw the rays. We have parallel ray, and it goes through the focal point. And then we have central ray, and then we have focal ray, then it goes parallel. When it goes like this, you can see the image is produced at 2F right here, and is inverted, a real image, and it is the same size as the object. Next we have case 4. Case 4, In case 4, the object is between F and 2F. So let's do the object there. Then we draw the lines. I put my 2F too far. Because you can't see it. There we go. And then we have the central ray. And then we have focal ray. As you can see, all of these rays form an image that is inverted, and it's going to be past 2F, but it's going to be a real image and magnified, so it's going to be a little bit bigger. And that's case 4. Next we have case 5. Case 5 is when the object is at F. Now I know I always draw it this way first. Okay. When the object is at F, we have the central ray, and the focal ray. And the parallel ray. It goes like this way. Since none of the lines cross, the image is at infinity. Finally, the last case for converging lens, we have 6. Case 6. Case 6 is when the object is in front of the focal point. What's unique about this is the image is actually going to end up on the same side. Oh wait. Image is supposed to be like this. Okay. Start out, we're going to draw the central ray. And then we're going to draw the parallel ray. And then we're going to draw the focal ray. As you can see, these rays cross here, and so the image will be magnified on the same side as the object and will be a virtual image. Now we have a diverging lens. A diverging lens is always smaller, the image is always smaller, virtual, and on the same side. This side is still the front, this side is still the back of the mirror. object here. So again, we have focal ray, except it's going to go back through this focal point. And then we have this other focal, that was the parallel ray. Then we have the other focal ray where it goes through the focal point and then parallel. And then of course we have the central ray. Where all these points meet, right here, is where the image is formed. And as you can see, it is smaller, virtual, and inside F. And there are all the cases.